Okay, next we're going to look at how to take derivatives of logarithmic functions. And so theorem 3.15 says if y is just the natural log of x function, then dy dx is 1 over x. And more generally for chain rule then, if you have that h of x is natural log of g of x, then it's going to be 1 over g of x times g prime of x. And that's just using the chain rule there. It's 1 over u times du dx is essentially what we're doing there. Okay, so let's just do a quick example so you can see how this works. So again, here, g of x would be x cubed plus tangent of x. And maybe I'll color code that. Okay, so that's g of x. So then you just calculate g prime of x and you get 3x squared plus the derivative of tangent of x, I think is secant squared x. And so then dy dx is going to be 1 over g of x, so that's x cubed plus tangent of x, times 3x squared plus secant squared x. And I guess another way that I usually write this is I just write this as if y is u of x, ln of u, then I usually write y prime is u prime over u, is maybe an easier way to memorize that. So again, this is, if you do it that way, u prime would be 3x squared plus secant squared x, and u was the x cubed plus tangent of x. So either way you look at it, it's basically just 1 over u times u prime or u prime over u. Okay, so the next example is natural log of e to the x plus x squared. So again, g of x, or you can write it as u, is e to the x plus x squared. That's what's on the inside of the natural log. And then u prime or g prime is going to be e to the x, the derivative of e to the x to e to the x, plus 2x. So we get that dy dx is 1 over u, which is the e to the x plus x squared, times u prime, which is e to the x plus 2x, which again you could have just written as u prime over u. And that's all it is. That's all there is to it for derivatives of natural logs. It's u prime over u. If you can remember that, you're in good shape. Okay, thanks for your time. Take care.